so today we're going to talk about simplifying exponents and log exponent conversion. So we have our 7 rules for simplifying exponents. Our first rule is b to the m times b to the n when your bases are the same, and this is important. The bases must be the same in order for this rule to work. When your bases are the same, you simply keep the base the same and add your exponents. So let's look at an example. So if we have an example of, let's say, x to the second power times x to the third power. The bases are the same, so we keep the base as x. We add our exponents, which gives us 5. Our second rule is the quotient rule, and this is where, again, we have the same bases, but this time we're dividing. So in this case, we keep the base the same, and we subtract the exponents, m minus n. So let's say we have x to the 5th power divided by x to the 3rd power. Since the bases are the same, we can keep the bases as x and then subtract the exponents, which would be 5 minus 3 is 2. Third rule, we have one base with an exponent, and then that's raised to another exponent, so we keep the base the same, and this time we're going to multiply our exponents, so m times n. So let's say that we have x to the 5th power raised to the 2nd power. We keep our base as x, and then we have 5 times 2 is 10. Okay? Let's move on to our last 4. Okay, this is very similar to a property we've already had, but in this case I have 2 bases inside the parentheses being multiplied together, and both of those bases are being raised to a single exponent. In that case, we're basically distributing the exponent. Right now, if we look at this, this is an understood a to the 1st and b to the 1st. So then we can use that property where we had an exponent inside and an exponent outside, and we multiplied the exponents. Therefore, we would have a to the 1st power times n, which would give us 1 times n is n. Then for our b base, we have keep our base as b, but then 1 times n is n. For our 5th property, this is very similar as well. We have 2 bases inside, but instead of being multiplied this time, they're being divided, and that's being raised to a single exponent. So you simply distribute that exponent onto both bases. So we keep our base of a with an exponent of n, and our base of b with an exponent of n, because these are understood ones here. So 1 times n is n, 1 times n is n. Therefore, a to the n over b to the n. Alright, our 6th property. This one is our negative exponent rule. So we have a to a negative n power. That negative is simply telling you that you need to take the reciprocal of that. In other words, change the location of this thing. Right now, this is understood to be over 1. So because this a to the n power is in the top of the fraction, this negative tells me that I need to change its location and send it to the bottom. When I do that, I lose the negative, which is the whole purpose of changing its location. Now with that rule, the reverse could also be true. Let's say that we have 1 over a to the negative n. That negative exponent tells me that I need to change the location of that. Because this negative exponent is in the bottom, that means it needs to move up to the top. When I move it up to the top, it loses its exponent. Now it's over 1, which can simply be written as a to the n power. So it works both ways. Anytime you see this negative exponent, that means change the location of this thing that the negative exponent is on. Only the base that the negative exponent is on. Alright, for our final property, we have what we just talked about here. The same thing. The negative exponent tells me to move that up into the top, which is over 1, and we just have a to the n. So these are really kind of the same property. The only other thing we didn't talk about, and we can write this as number 8, is our simplest property yet. So let's say we have x to the 0 power. And x can be anything except for 0. So if we have something, anything, to the 0 power, that is always going to equal 1. No matter how simple or complicated it is, if it's raised to the 0 zero power, then the answer is just 1. So we could have x squared, y to the 4th, z to the negative 5th. But if I raise that entire thing to the 0 power, this is just 1. Okay? Alright, now let's move on and do a few examples. Okay, in this first example, we have two things being multiplied together. So we need to look at each of these as kind of separate things all put together. This is 5 times x cubed times y to the 4th. Then all of that multiplied by 20 times x to the 7th times y to the 8th. So we take these piece by piece. The first thing that we're going to do is look at our numbers. So we have 5 and 20. If I multiply that together, I'm going to get 100. Then I take a look at my x's. I have x to the 3rd times x to the 7th. My bases are the same, so I keep it as a base of x, but then I'm going to add the exponents together. So this would be 7 plus 3 is 10. Then I do the same thing for the y's. Y to the 4th times y to the 8th. Bases are the same, so I keep the base as y, but because this is multiplication, we add the exponents together, which gives us y to the 12th. And that's it for number 1. Number 2 is very similar, but instead of being multiplied together, these are being divided. So if multiplying means we add the exponents together, then dividing means that we're going to subtract them. However, remember that our numbers, our coefficients in front, are still going to work the same as they always have in the past. So we're going to take a look at this, and we're going to have 36 divided by 4. Well, if we take 36 over 4 and we simplify that fraction, we get 9 over 1. And we may or may not need to keep that 1. We'll find out when we're done. Then we look at the x's. We have x to the 12th over x to the, remember there's an understood 1 here. So the bases here are the same, so we keep the bases the same, and we subtract the exponents. So 12 minus 1 is 11, and that x to the 11th power is going to go on the top of the fraction because that's where we have the most x's to begin with. And another way that we can think of this is, remember that these are 12 x's being multiplied together. This is 1x on the bottom. So then we're going to have a single x from the top, cancel with this single x from the bottom, which leaves us with 11 x's on the top. Then we look at our y's. Same thing here. We have 4 y's on the top, 2 y's on the bottom. After we cancel our 2 sets of y's, 2 on the top with these 2 on the bottom, we're going to have 2 y's left over on the top. So y squared. 4 minus 2 is 2. Okay? So that's it for number 2. Oh, actually not quite. If all I have left on the bottom is a 1, then really this is the same thing as kind of like a whole number. So I don't really need that 1 on the bottom. So I can just write this as 9 x to the 11th, y to the 2nd. And that's it. Okay, let's take a look at number 3 then. All right, for number 3, we have that negative exponent, which means that we're going to have to change locations. So, if this negative exponent is on the negative 2, that means that negative 2, that base, needs to move to the top. It was in the bottom to begin with, so it needs to move up to the top. So if I move that to the top, the only thing that changes from moving this from the bottom to the top is that I lose that negative exponent. That's it. Everything else stays the same. It still stays a base of negative 2. We still have an exponent of 4. It's just not negative anymore. Since there's nothing left on the bottom that didn't get moved, we always still have that understood 1 there. Now we just have to look at this and decide, can I simplify this? Well, sure. We can do negative 2 to the 4th power. We know that negative 2 times negative 2 is positive 4, times another negative 2 is negative 8, times another negative 2 is positive 16. So this is really just 16 over 1, or 16. That's it. If you can simplify this, you always do so. Sometimes it's going to be a large enough number that you'll leave it in exponential form, but most of the time, you've got a calculator, you can use it, simplify that to get a normal number. All right, for number 4. Now in this case, I have some negative exponents. However, I also have to notice that the b does not have a negative exponent. Since the b doesn't have a negative exponent, that means it's good to stay right where it is. I only need to move the bases that have negative exponents. So that tells me that this b to the 7th power is good right where it is. So in our fraction, we're going to leave that as b to the 7th power on top. No change needed. However, if we look at this a to the negative 4th power, that negative exponent tells me I need to move it. So the base stays the same, the exponent stays the same, except that we lose the negative. So we're going to take this entire piece and we're going to move it to the bottom and lose the negative exponent. Exponent stays, just lose the negative. And then the last piece to deal with is the c. The c also has a negative exponent, which means it needs to change locations. So it's in the bottom now, we're going to move it up to the top. So I would probably prefer to put my c after my b, because that whole alphabetical order thing. So we're going to move it back here, but it now will be a positive 3. And then I'm just going to write it a little bit neater, because there's absolutely nothing here that will simplify. And that's our answer. Okay? Then for number 5. Okay, on this one, we've got a few things that we need to do. I've got 2 negative exponents, but I also notice that I have an exponent on the outside. So these things are both being raised to the negative 4th power. Now there's several ways that you can go about this. There's not always one direct route to the answer. Sometimes you can take multiple pathways and still get to the same place. So one thing that you could do is you could go ahead and distribute that negative 4 exponent, in which case I have to multiply those exponents. So I'm going to keep the base as a, but then multiply negative 3 times negative 4 gives me a positive 12. Then on the bottom, remember, distribute it to both things. So keep the b as my base, but then 5 times negative 4 is going to give us a negative 20. Then you can look at your exponents and decide, does anything else need to be done? Well, these are different bases, so they can't be combined. However, I have a negative exponent. And I know that with a negative exponent, that means I want to take this entire piece and I want to move it up, which when I do, it loses its negative, and then I would have just a 1 on the bottom. So I would have a to the 12th would stay on top because it does not have a negative exponent. But this b would need to move up and become a positive 20 now. Nothing left down here because we moved everything up, so it's a 1. However, don't really need to write the 1. The a and b can't be combined because they're different bases, so we have a to the 12th, b to the 20th, and that's it. All right, let's take a look at 6. Okay, similar thing here. We have a negative exponent on the outside. We also need to understand, remember, that this is an understood 1, and this is an understood 1. So I'm still distributing that negative exponent, which means multiplying by the exponent that was previously there. So this is going to be 2 to the 1 times negative 4 is negative 4. And then I have a to the 1 times negative 4 is negative 4 over, now this is not in my parentheses, so this is not being raised to the negative 4. So it's just going to stay b to the 3rd power. Now I look and see, okay, I have some negative exponents, so I need to deal with those. So we have this negative exponent, which means this entire thing needs to move from the top to the bottom, remains exactly the same except it loses the negative. So I'm going to have down here a positive exponent on my 2 now. Then I also have a negative exponent on the a, which means that entire term needs to move down to the bottom and lose its exponent. So, putting them in alphabetical order, I'm going to stick this in front of the b. That b is not going to have to go anywhere because it has a positive exponent. So we have a to the 4th, and then we will just leave our b there. And then, since both of these move to the bottom, the only thing left is the understood 1. Now the very, very last thing that we can do is, I can figure this out. So, in fact, we already did it with a negative 2, positive 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to give us 1 over 16 together to simplify a more complicated problem. All right, so now number 7. Okay, number 7, if you notice, is almost the same as number 6, with one very important difference. In number 6, I have parentheses telling me that both the 2 and the a were being raised to the negative 4th power. In number 7, there's no parentheses, which tells me that only the a is being raised to the negative 4th power. The 2 is not. This is 2 times a to the negative 4th power, which means that in this case, that 2 doesn't change. It just stays a 2. But then we have this negative exponent. Remember, only the a is being raised to the negative 4th power, so only the a is going to move. So we're going to take it from the top to the bottom, which is going to give me a to the positive 4 in the bottom. B has no negative exponent, so it's fine to stay right where it is. So we're going to leave that down on the bottom, and then decide, is there anything that needs to be simplified? Well, there's no exponent on my 2, so it's fine. These can't be combined. There's nothing top and bottom that needs to be canceled, so that's simply our answer. That's it. So 2 very similar looking problems, but 2 very different looking answers. So we have to be careful with where that exponent is, whether there's parentheses, and what all of that means. Okay? Now we're going to move on and get just a little bit more complicated. Not a lot, but a little bit. We take a look at number 8. Okay, we have parentheses here with a negative exponent, which means all of this that's in here is being raised to the negative 3rd power. We have to remember that this is an understood 1 here, which means I'm taking this negative 2 and I'm raising it to the negative 3rd power. So let's write it out. So if I take the negative 2 and I raise it to the 1 times negative 3 is negative 3, then I take this x and I raise it to the negative 4th power. 2 things in here making up this negative 2x to the negative 4th, both of them being raised to the negative 3rd power. Ooh, hey, that's wrong. Actually, negative 4 times negative 3 is going to give us a positive 12. That's much better. All right, then we look at this and see, do we have any more negative exponents or anything that needs to be simplified? And of course, our answer is yes. So we look at this, and this is going to be negative 2 to the negative 3rd power. The first thing I'm going to do is take care of that negative exponent, so we don't have to worry about that anymore. So we're going to look at that, and we're going to say, okay, well right now, this is understood to all be over 1. So we have this thing that needs to go into the bottom of the fraction, from the top to the bottom, which is going to give us a negative 2, but now it's going to be to the positive 3 power. This has a positive exponent, so it is good to stay right where it is. So we have x to the 12th power. All right. Now we can also figure out what this is. Negative 2 to the positive 3 power. So negative 2 times negative 2 is positive 4, times another negative 2 is a negative 8. So we're going to rewrite this as x to the 12th over negative 8. And that's it. Some of you will prefer to write it. You could also write it as 1 over, or negative 1 over 8, x to the 12th. I would be good with this, but technically this is correct as well. Just don't forget that you have a negative there. All right, number 9, our easiest problem of the day. We have this very large, scary-looking fraction. However, we notice there's a parentheses around it with an exponent, which means that everything inside of here, everything, is being raised to the 0 power. And we said that anything to the 0 power is 1. So this whole thing just equals 1. That's it. Don't care what's in there. There's a parentheses with a 0 up there. Your answer is 1 every time. All right, number 10. Okay, number 10, there's no parentheses with exponents outside of it, so that means I don't have to distribute my exponent and all that good stuff. What I do need to look at, though, is what will simplify. And again, multiple routes to take here will all get you to the same answer if done correctly. What I'm going to look at first is each piece, okay? So, actually, I think we're going to move negative exponents first and simplify it. So let's do that first before we deal with anything else. So we're going to leave this. We're going to leave a negative 24 on top, and we're going to leave the negative 8 on the bottom. We know that that's going to simplify, but we're going to do that in a minute. Okay, so we know that this is fine. That's going to stay because it has a positive exponent. So we're going to leave that as a to the positive 2. However, we look at this a and say, it has a negative exponent, so it needs to move from the bottom to the top. So this is going to move up. All right, we have this is going to move down. This is going to move up. Negative exponents. This is fine to stay where it is. This is not. Negative exponent means it needs to move up. So let's rewrite everything. Don't worry about simplifying yet. We're just going to move everything where it needs to be, and then we'll look at simplifying. So we have this one could stay. This one moved up. So that's a to the positive 5. Then these two basically switch places. So we have b to the positive 3 on the top, and then this moves down to the bottom to become b to the positive 2. The c to the 8th is good on top because it's positive. However, this c, because of the negative exponent, means it needs to move up. So we have c to the 3rd power. Now all we have to do is look at all of this and get it all simplified. So the first thing I'm going to do is the basic stuff. Negative 24 divided by negative 8 is going to be a positive 3. So we have equals positive 3 or positive 3 over 1. Chances are I'll be able to lose that 1, but we'll make sure later. Then we'll look at our a's. We have two a terms. They are both on the top of the fraction, which means they're being multiplied. This is a to the 2nd times a to the 5th, which means we're going to keep that base, but we're going to add our exponents. So 2 plus 5 is 7. Now we'll look at our b's. We have, so b squared and b to the 3rd. One's on top, one's on bottom, which implies division. Therefore, when the bases are the same, we can subtract our exponents. So 3b's on top, 2b's on the bottom. They cancel to leave us a single b on the top. Don't really need to write the 1 here, but it's there. And then the last thing is our c's. Both on top being multiplied together, so that gives us c to the 8 plus 3 is 11. Okay, so when we look at this, I didn't have anything left on the bottom, which tells me I can totally lose that and just write it as 3a to the 7, b, c to the 11. And that's it. All right, bear with me just a little bit further. Okay, now on this one, we've got a bunch of stuff going on. So we need to get all of this simplified down. So the first thing that I'm going to do is I'm going to distribute out all these negatives, or all the exponents on the outside of the parentheses, which on the top happen to be negatives, but not here. This one's not negative, so we've got to notice that. So we're going to distribute all that out. Then we're going to see what we'll combine, what we can divide, all that good stuff. So we'll start with everything here to the 1st power, including the 3, because remember, there's an understood 1 on that 3. So this is going to give us, on the top, we have 3 to the 1 times negative 1 is negative 1. Then we have our x to the 3 times negative 1 is negative 3. Then we have y to the 2 times negative 1 is negative 2. Then I'm going to do the next parentheses. Okay, remembering this is an understood 1 here. So, base of 2. So times 2. 1 times negative 2 is negative 2. Then our x, we have 2 times negative 4, or sorry, 2 times negative 2 is negative 4. And then y, this is an understood 1. So 1 times negative 2 is negative 2. Okay, so that's everything in the numerator. Now we're going to do the denominator in the same way. Then we'll see what will simplify. Okay, first parentheses. We have an understood 1 here. So we have x to the 1 times negative 5 is negative 5. Then y to the negative 10 times x to the positive 6 and y to the positive 9. Remember, we're multiplying, not adding. Now we look at all this and see what will simplify. Again, multiple ways you can do this. You can simplify everything up here and everything down here. You could start canceling things. You could move all of your negatives. I'm going to choose to go ahead and combine things and then move them because I don't want to have to move 9 million things and then combine and maybe have to move again. So we're going to combine first and then move it. So we have 3 to the negative 1. Remember, I'm not moving anything yet. I just want to combine my variables. That's it. Okay, then times 2 to the negative 2. When we get all those moved, we can multiply them out and get them all simplified. But for now, we're just going to leave it. Then we have x to the negative 3 and x to the negative 4. So we add our exponents, which gives us x to the negative 7. And then y to the negative 2 plus negative 2 is negative 4. All right, then on the bottom, we have x to the positive 5 and x to the negative 5 and x to the positive 6, which gives us x to the positive 1 power. And then y, negative 10 plus positive 9 is a negative 1. Now I can look at all these negative exponents and I can move them where they need to be moved. So I know that this needs to go down, 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 that can stay because it's positive, and this needs to go up. Alright, so almost everything here is moving, almost. Now we just have to move everything where it needs to go and simplify. So if we move this down, we're going to have 3 to the first times 2 to the second times x to the 7th times y to the 4th. Then this gets to stay on the bottom as x to the first, and this moves up to the top, y to the first. Then we simplify. So first thing we'll do is take those, and if we multiply, this is really 3 times 4, which is 12. Then I'll combine my x's, which I'll keep the base the same, but then I'll add these two exponents to get x to the 8th. And then we'll take our y's, and if I have 1 y on top, 4 y's on the bottom, that leaves me with 3 y's left over on the bottom, and then we just put that understood 1 up top, and that's it for that one. So just combine what you can and leave the rest. Alright, now the last thing that we need to talk about real quick is how to convert logs to exponents and exponents to log, which we'll be using a lot for the rest of the week. Your rule, if you have y equals log base b of x, all you do is really arrange all the components. So it's log base b. So b is my base, therefore b is your base in the exponential form as well. But instead of b being connected to the x, it will now be connected to this y over here. So b to the y equals x. b to the y equals x. Okay? So if we look at a couple examples with that, using our rule, this is log base 3 of 81. Therefore, we know that our base is 3, but instead of it being 3 to the 81st power, it's 3 to the 4th power, equals 81. And then likewise over here, log base 6 of 36, our base is 6, so 6 to the x power equals 36. Sorry. And we could also very easily simplify that. 6 to the x power equals 36. Well, in order for 6 to some power to equal 36, it would have to be 2. 6 squared equals 36. Now we can also use that same rule, but in reverse. This time they're going to give us the exponent form and ask us to write it as a log. So, base b to the x power equals y, which tells us we're going to have log base b of y equals x. Log base b of y equals x. And you can write it either with the log first equals x, or x equals and then the log. Either way, it's the same thing. So if we look at our example, we know that our base is 5, our exponent is 2, it equals 1 over 25. So you're going to put your log. It's going to be the base of 5 of 1 over 25. And I would put that in parentheses so that we know that it all goes together. And then it will equal your exponent, which is -2. And that is it for today. Hope you enjoyed it. See you tomorrow.